Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. Our topic today is Basic Electronics, and we'll be looking at transistors. Please follow us in this lecture series by subscribing, like, and share so that subsequent modules will be brought to your notification. We'll be looking at junction, otherwise known as the bipolar transistor. A bipolar junction transistor, otherwise known as the BJT, is a three-terminal active device that may be used to control flow of current through a load from an external power source. It is the second-level application of semiconductors, that is N and P type materials, in electric circuits. Its primary application is for amplification of current and voltages. A junction transistor is basically a combination of two junction diodes and consists of either a thin layer of P-type semiconductor sandwiched between two N-type semiconductors, that is NPN, or a thin layer of N-type semiconductor sandwiched between two P-type semiconductors, referred to as a PNP transistor. It is called BJT because both polarities of charge carriers are involved in the movement of current. The transistor symbol is shown in Fig 6. The device has three terminals: the emitter, the base, and the collector. The flow of majority carriers is between emitter and collector and is controlled by means of the voltage applied between the base and the emitter. The transistor is widely used in electronic circuits for such applications like amplifiers, oscillators, switches, filters, and so on. The arrow of the emitter terminal indicates the direction in which conventional current would flow in normal operation. In the case of the NPN, conduction is mainly due to the flow of electrons. In the PNP, the conduction is mainly due to the presence of holes, that is, electron vacancies. So, Fig 6a shows the convention of the NPN. Here, the arrow in the emitter is pointing out, while in the PNP, the arrow is pointing in. It is important to note the convention. The circuit configuration for the junction transistor can be arranged in any of the three ways as shown in Fig 7a to C. The arrangement of Fig A is referred to as a common base configuration. Here, the collector current is slightly less than the emitter current, and when used as an amplifier, this current does not give current gain, although voltage and power gain is possible. Fig 7b shows an arrangement in which the emitter is the common terminal. This common emitter circuit is the one most frequently used in amplifiers. Current as well as voltage gain is possible. The third arrangement shown in Fig 7c is called the common collector circuit. This can produce a current gain, but the output voltage is less than the input voltage. Let us look at transistor as an amplifier. One of the most important applications of transistors is in the area of voltage and current amplifications. Electrical components are said to be active if they possess the ability to amplify their inputs, and passive if they lack the ability to amplify their inputs. The extra energy required to achieve this amplification by the transistor comes from the external power source, normally known as VCC. The BJT is the most common active device used in electronic systems, so they have to be connected appropriately in circuits for them to work correctly. For example, the arrowhead in the emitter indicates the direction of normal conventional current flow. Some standard subscripts are normally used to indicate specific voltages and currents associated with transistor operations as shown in Fig 8. Normally, when you are working with transistors, you will be hearing Vin, Vb, Ib, Vbe, Ve, IE, VCE, VE, VL, IC, VC, and VCC. It is very important for you to note anytime you see any of these terms where in the circuit is being referred to. So the meaning of all those are stated here and the possible combinations. A small current flowing between the base and the emitter junction will allow large current to flow between the collector and the emitter, thus making the transistor to be both an active device and an amplifier. Therefore, the current gain of a transistor is defined as current gain equals collector current over base current, that is IC over IB. This is so because IB is usually very small compared to IC, which makes IE approximately equal to IC. The standard adopted for transistor current gain is H subscript FE, where the FE in capital letters denote that the circuit under consideration is a DC circuit, and FE in small letters is an indication that the circuit under consideration is an AC circuit. For instance, if the transistor is used to amplify an AC signal, then the change in the base current, delta IB, will produce a change in the collector current, delta IC. Therefore, HFE will be equal to delta IC over delta IB. Transistor as a switching device, that is another application. Transistors many times are used as a switching device in many applications. When current is applied to the base of a common emitter configured transistor, the flow is negligible until the voltage is above 0.6 volts. Above 0.6 volts, the resistance between the base and the emitter junction begins to change, such that the base emitter voltage remains at most at 0.7 volts. The transistor is then said to be saturated, and any further increase in the base current has no further effect on the collector current. The transistor is then said to be fully on. It is a rule of thumb, therefore, to assume that when the transistor is in the on state, the VBE, that is the base emitter voltage, is equal to 0.7 volts. Note also that if VBE lies between 0.6 volts and 0.7 volts, the transistor acts in an analog manner, and this may result in the output swinging between the on and the off states. Darlington pair. In some instances, the current required to operate equipment connected to the output of a transistor may be too large for the transistor to handle. In such circumstances, the transistor circuit may be used to drive a relay which controls the equipment. The contacts of the relay are then used in a separate circuit to operate the circuit to be controlled as shown in Fig 9. However, in order to obtain enough gains required to operate moderate loads, more than one transistor can be used in a cascaded form, where the output from one transistor is amplified further by the next stage, thereby increasing the overall gain of the transistor. Increasing the gain of a transistor means that 1. The switching action of the circuit is more immediate. 2. A very small base current is required in switching. And 3. The input resistance is very high. Fig 9 shows where you can use the transistor to control a relay, and the diode here prevents any feedback to damage the transistor. So Fig 10 also shows the Darlington pair where the transistor 1 and transistor 2 are combined to give higher gain. A popular way of cascading 2 or more transistors is to use a Darlington pair as shown in Fig 10 above. The current gain of the pair is equal to the product of the two individual HFEs. That is, the current gain is equal to the product of HFE1 and HFE2. Note, BJT has the advantage of possessing good current gain, that's a HFE, and good transconductance when compared with their competitor field effect transistors. Its disadvantage is poor stability of operating point with temperature, high noise, poor distortion, high intermodulation products, and low input impedance when used in the common emitter mode, which is the most popular, or the common base configuration, and a high risk of thermal runaway. Thank you for listening. Please drop your comments in the comments section.